All right, so today we're going to do our transformation review. So this is what it looks like, and I'm going to go through each problem with you in this video, and then you're going to get your answers and then post them on Canvas so that you'll be ready for the test tomorrow. So let's get started. So our first problem, number one, we got a parallelogram with these vertices, and we're going to reflect it in the y-axis. So the first thing we want to do is write the rule. So there's the rule. All the x, y values will become negative x comma y when you reflect it across the y-axis. And so we look at each of these coordinates up here and we write down the new coordinates with this translation or transformation taking place where we reflect it across the y-axis. So x in our first number was 1. Our new x is going to be negative 1, as you can see. So once we have our new coordinates, we plot the original, and then we plot the new one, and then we draw the lines so that we can see the two shapes. And sure enough, you can see how this has been reflected across the y-axis. So those are your numbers. If you need to pause the video to get those numbers or to watch what happened, you can certainly do that. Next, we have a trapezoid, and we're going to reflect it across the x-axis. So the rule for reflecting across the x-axis is that x stays the same, y becomes its opposite. So using these first four coordinates that we had up here and following this rule, our four new coordinates will be negative 7 and 2, negative 4 and 1, negative 2 and 5, and negative 8 and 7. So using those numbers, we're going to plot the first one. That's the original or pre-image. Plot the second one, which is now the image, and we can see how that it did get reflected across the x-axis and is now above the x-axis, whereas it started out below the x-axis. All right, this next one, we've got a triangle with these three corners, and we're going to translate it along with the rule x plus 9, y plus 4. So let's start by drawing the initial shape. As you can see, we've got negative 2 and 3 right here, negative 1 and negative 7 down here, and negative 5, negative 1 back here. So now we need to plot the change in x. So in each point we count over 9 spaces because of this plus 9. And next we count up 4 spaces from there and create dots at each of those locations. Then we can use those 3 dots that we had to draw our new triangle. And that new triangle has these points, 7, 7, 8, negative 3, and 4, and 3. So that is our new shape after it has been translated x plus 9 and y plus 4. In this case, we have a quadrilateral. We're going to translate it 3 units left and y units up. So here's the original. And we notice that we go 3 units to the left and then 1 unit up. So we've got 4 new points at the top of those pink little lines there. And then we draw our new shape going between those 4 new points. And here are the x and y values for those 4 new points. So if you see that, it's pretty straightforward. On this next one, we're going to do a rotation. So we have a rectangle. We plot the original rectangle. And we're going to use a counterclockwise rotation about the origin. And we're going 270 degrees. So that means that we'll use this formula. xy becomes y comma negative x. And this thing is basically going to, because it's rotating counterclockwise, it's going to rotate around this way and end up in quadrant number 2. So if we use the rule with the original points, we plot our new points, there they are. Now we plot the shape up there, and just sure enough, it's in quadrant 2, so that was a 270 degree rotation. And there's the new coordinates that go with it. Number 6, triangle RST with vertices 2, 6, 6, 7, and 8, 1. We're going to do a 180-degree rotation. So I've already plotted this up here. Now the formula or the rule that goes along with a 180-degree rotation for x, y is that they both switch to their opposite signs. We have negative x and negative y. So we've plotted the pre-image. We've used the rule to find the new points. And now we're going to plot those points and draw the shape that goes with them. And those are the ones that are marked with S prime, R prime, and T prime, as you can see there. All right, so moving on. In this case, we got a rhombus, which is kind of like a little square, but not necessarily in 90-degree angles. We're going to go a 90-degree counterclockwise rotation about the origin, which means that we're going to have a coordinate change of x, y. I'm going to change that to a y. X, y becomes negative y, x. So first of all, we graph the first 4 points and plot them on the coordinate system. And so this particular image is in quadrant 4. All right, so when we calculate our new coordinates using the rule, we end up with 0, -1, -2, -6, -7, -8, 5, and -3. And then when we plot those points, they end up being in quadrant 4 because that's what we'd expect with a 90-degree clockwise rotation, which means just 1/4 turn backwards. So there's the new image and the coordinates that go with it. All right, on number 8, we have a quadrilateral with these coordinates and a 180-degree rotation. We end up with the same numbers, only they become their opposites. So -6 and 5 becomes 6 and -5. -4 and 7 becomes 4 and -7, and so on. So I've got the originals and the new ones plotted on this rotated image, and there's the coordinates that go with it. So kind of step by step, there's the pre-image, there's the coordinates of the new image, and there's the new image having been plotted. Okay, triangle LMN with vertices 1 and -2. So we're going to plot the pre-image. Use the rule by multiplying everything by 5 to get the new image. And that looks like this. So that's a dilation with a factor of 5, so we just multiply everything by 5. Next, we have a parallelogram with vertices shown there with 4 different corners. And in this case, we'll plot those corners, connect them with the lines. And now using this formula, multiplying everything by 3/2, or which is the same as 1.5, we get our new numbers for our new parallelogram, and that looks like this. So we plotted all the new coordinates and added the lines, and so we do have a rectangle whose sides are 1.5 times bigger than the original. Okay, so we've got here on number 11 a transformation, and we want to name the transformation and write the rule. So this is a 90-degree counterclockwise rotation, and the rule for that type of a rotation is x and y becomes -y, x. And so here's what the new coordinates look like after we go through that particular rotation. Number 12, as you can see, we got the bigger image, and then we got the one with the little prime mark, so that's going to be so the pre-image is on the outside, the regular image is on the inside. So we've actually got a transformation, which is called a dilation. And in this case, we have to use any two of the coordinates of these points. So when we start out with r prime, which is 2, -1, and then r, which is 4 and 2, and we set up a ratio between r prime and r. So we can do 2 over 4 or -1 over 2. That's actually a -2 there. So we've got to make sure we put a negative sign in front of that. So if we make a ratio between either of those, we end up with 2/4, which equals 1/2. So that is the key to that, doing r prime over r, and make sure you got the signs right, and that's how you get your scale factor. 13, what is this transformation? Well, what's happening is we've got a reflection over the x-axis, and so when you go across the x-axis, the shape is reflecting up or downward, meaning that the y value is changing. So x stays the same, y becomes its opposite. On number 14, in this particular translation, we start over on the left side and with our pre-image and move over to the right side. So you can see it's only sliding in one direction, and that's in the positive x direction. And we count 1, 2, 3, 4, 5, 6, 7, 8. So it actually goes over 8 spaces, but doesn't go up or down anymore. So that's our translation. So now post your answers on Canvas and get a little bit of reviewing done, or finish up any other work that you have and be ready for the test coming up tomorrow. Thank you very much.